Okay, class, let's look at another example that's not a Ferris wheel, that's not a circle, but it still uses periodic motion and can be represented then using the sine function. So right here I have a situation. This is my f of x, where I have 4 times the sine of pi over 12x plus 10, and I have information about this is modeling the height of the water on a retaining wall for a tidal river. If you've never heard of a tidal river before, a tidal river is a river that is controlled by the tide. It will come up the riverbanks and it will go down in the riverbanks during the tidal flow of the day. So rivers do that. In fact, one of the famous rivers that does that is the Thames River in England. It is a tidal river. So the tidal river, this is representing that height of the water on the retaining wall. X is told to be in hours, and then f of x we're given in feet. So let's take a look at the knowledge that we can find by looking at this formula. At first glance, I see that there's a 4 in front of the sine. That 4, if you remember about waves, gives the amplitude of the wave. Well, the amplitude of a wave always gives us the height above or below a midline. So the midline would represent this in the situation. The amplitude is giving us this information here about how high or how low things are. The amplitude is usually given in a positive direction. So the amplitude in this case is 4. Okay, well that's not really that useful to know that, but a better question might be to ask something about how high, the maximum height this water will get. That's important because you're built a retaining wall. You want to retain the wall from going into the water. So you don't want the water to get so high that it starts to erode the riverbanks. So knowing the maximum height of the river is going to be very important. We also might want to know where the minimum height is. Let's say you put a dock on this river, right? You don't want your boat to be ending up grounded every day and perhaps cause a break in the bow of the boat and sink a boat. So knowing the maximum and minimums are important when you're doing anything with a tidal river. So let's kind of look at the rest of our equation and see if we can figure out perhaps where those are. This 10 on the end is a good indicator of something. That 10 is indicating the height of the midline. If this were a circle, we'd say the center of the circle we're at 10. This isn't a circle. This is the water coming in and coming out. So what this is actually the average height, the midway height of the water on the retaining wall. So this would represent 10 feet. So when the tide is in between in and out, you're at 10 feet high in the river. Well, what that means then is that a maximum height of the river will take this value of 10, the midline, and add to it this value of 4, giving us 14 feet. This water can come as high as 14 feet up the tidal retention wall there. And the minimum value of this river is going to reach a value of 10 feet minus the amplitude, which will then be 6 feet. So we now know that this river gets as low as 6 feet deep, but as high as 14 feet deep, and averaging a value of 10 feet deep. The next information we can glean is this right here dealing with the number in front of x. Well, if you remember from the general sinusoid, this number in front of x is the angular velocity. Okay? Well, angular velocity is telling us that we can go pi over 12. Well, let's put that in terms of a cycle. Pi is half of a cycle of a sine curve. 2 pi is a full cycle, 6.28 seconds, 6.28 radians. So in this case, pi over 12 would be half a circle. This can now go half of a circle in 12 hours. Well, let's put that in perspective of a full cycle then. If I can go half a cycle in 12 hours, then a full cycle will be 24 hours, a full day. So we'd see a full cycle in 24 hours. And that's convenient, right? Because a day is 24 hours long. That would make sense. So the pi over 12 is giving us information about the period. Period is equivalent to, normally we would say it's this bottom number, but because it's a pi, we're going to double this, and this becomes 24 hours. Okay? What I'm doing is comparing the fact that pi over 12 would be equivalent to 2 pi over 24. And 2 pi is a full cycle, where pi is half a cycle. So we get a period of 24 hours. We get all that information just by looking at the sine curve. Now, if this is a wave, you wouldn't have to start measuring at midway. What if you arrived at the river, and instead of being at midway, you actually knew you were at high tide? Well, in theory, what you're going to do then is be shifting the high tide over to our measuring starting here. Well, one way to do that is actually to take our curve and move the curve this distance to the left. And that would give us then the same exact shape, but we'd be further to the left for a starting position. Well, there are several ways to think about that. If I want to go to maximum point and I want to move this to the left a quarter of a cycle, I could take a quarter of the period of 24 hours, 24 divided by 4 being 6 hours, and I could actually go ahead and place that in here by doing 4 sine of pi over 12 times x minus the quarter turn. Well, I got to be careful here. I want to go to the left this time, not to the right. So to go left, I actually have to add 6, like so. That would be one modification in order to get the tidal river to start off at its maximum point instead of at its minimum point.